Hello and welcome to the final part for the exercises of loops. We already have completed the two sections for exercises. Um, Let me check once. Yep, everything's good. So we will be doing 5 problems today. First, we'll go with the perfect number one. Then we'll jump off to probably the next thing that we'll be learning is about digit counting, then reverse number, then Armstrong number, and then finally Palindrome number. That's it. Okay. So, all right, with that, we can get started. So, first of all, what is a perfect number? If we want to understand this in a little bit more detail, so I'll just show you what this means. So, basically, now you know that how to, um, take out the factors of a number, right? You know how to do that from the previous video. If you haven't watched that, please do give a watch. You will understand how to find out the factors of a particular number, right? So a perfect number is a number whose sum of factors is same as the number. Now, what do I mean? So basically, let's take a number. Let's say 6 is the number. What are the factors of 6? So factors of 6 are 1, 2 3s are 6, 3 2s are 6, 6 1s are 6. Now, you don't need to take into consideration, this one obviously, because obviously it's the same number, right? You don't need to take this into account. But other than that, if you add 1, 2 and 3, you can exclude the same number because you can ignore it, right? So if you do that, 1 plus 2 plus 3, what does it give you? 1 plus 2 3, 3 plus 2 1 plus 2 3, 3 plus 3 6. So this gives you 6, and this is why 6 is a perfect number, right? The sum of factors is equal to the same number. All right, so this is what is called a perfect number in mathematics. So how we'll be building the algorithm? Now let's look onto that. So as you can see, we need to find out factors, and yes, this time we need to start from 1. Do not start from 2, you need to start from 1. All right, so with that in mind, we can find out the factors. So basically we'll have a loop. I'm not going into detail because I have already told you how to find factors. So we'll have I variable that will start from 1, okay, and that will go say I less than equal to, because it has to go exactly up to the half of it, right? Because after half there is no factors, like 4 isn't a factor, 5 isn't a factor, right? So it's always going to be the same for all the numbers. So you need to go till the half of the number. So let's say the given number is n, so you need to go till the half of it, okay? And every time you do a increment. So yeah, this is the loop. Now you need to add every factor. So first of all, you need to find factors. How do you do it? How do you find factors? So you just going to say if n, the given number, mod I, whatever the value of I currently is, it perfectly divides with a remainder of 0. I mean, mod is basically the remainder. So if the remainder is 0, that means it is a factor. It's that simple. That means it is a factor of n, right? So you need to keep adding the factors. So you need another variable. Let's say sum. Initially keep it 0. Okay, say int sum before the loop. Keep sum equal to 0. Okay, and once this condition matches, what you're going to say is sum plus equals to I. I mean, every time keep adding I. Okay, do this. Okay, so once you are done, oh, I forgot to put the brackets. Okay, fine. and yeah, this one. So yeah, once you're done with the entire loop, you are going to check if sum, that is the added value, is equal to n. If it is the same as the given number, then it is a perfect number, else it is not a perfect number. Make sense? That's pretty much it. Now let's build this algorithm, right? Obviously we'll be taking input from the user, so let's open up our favorite IDE, BlueJ. Yep. And let's start by making a project. Oh no, by making a class. Let's call it perfect. Too many programs. I guess I will change the project after, maybe in the next video I'll change the project, Anyway, so here is our class. We'll go into this. We can minimize this. We don't need this. So yeah, remove all these things. You don't really need this. You don't need this as well. Yeah, now we're good. So you need to take input from the user. So import java.util.scanner and just our good old main function, public static void main string args. So first things first, create the scanner object. Scanner sc is equals to new scanner system.in. Now show the user that you need to enter a number. So system.out.print, not ln, just print, say enter a number. Okay, so the user will then enter a number. You take it input into n, so int n is equals to sc dot next int. Right, obviously we'll be taking an integer for these things, and we are done. Now we are going to start the loop. Now before the loop we need another variable. Like I said, we need a variable, and let's call it sum, and initialize it to 0. We don't need anything else at the moment. And then you just start the program, just the for loop for int I equals to sorry for that, starts with 1, and I has to go exactly till the half of n. I'll put brackets, and then simply I plus plus. That's the basic for loop condition. And inside the loop, if this is how we find factors, if n is divided by I and the remainder is 0, then it is a factor. So every time this happens, we can write on the same line, right? If it's just a single statement, we can write exactly on the same line. We can obviously do this. We can say this sum plus equals to I. We can do this obviously, but we can write in the same line as well. But it's perfectly fine. Both are okay. Let's go with this syntax only. So we are done. Now all you need to do is to check, okay, if sum equal n, then what do? You say system.out.println and say system.println, say given number is a perfect number, and if this condition does not match, system.out.println given number is not a perfect number. And that's it. Our program is ready. Let's compile this and test it out. Right, compile. Class compiled, no syntax errors. All right. It started. Okay, enter a number. It's asking us to enter a number. So say 6 just to test. So 6 is a perfect number. Why? Because 6 has factors of 1, 2 and 3. So 1 plus 2 plus 3, right? That is how the things work. Hope you are getting it. And yeah, that's pretty much it. I mean, I can go on and explain a little bit more just so you understand what's going on. I'll take a screenshot. If you have already understood, you can go to the next problem. For now, I'll be doing this. Okay. Let's copy this. Let's go back. Let me show you the dry run of it. Okay. Okay, now understand what's happening. Okay. So here we go. Say the given number is 6. Okay. So the user enters 6. Oops. User enters 6. Perfect. So n is 6 at the moment. So we have two ongoing variables. Okay. First is our sum and second is our I. All right. So initial value of sum is obviously 0. I'm not even taking that. So see, yeah. So the loop starts over here. The loop goes from where? It goes from 1 to half of the given numbers, that is 6. 6 by 2, that is it goes up to exactly up to 3. Okay, 2, 3, 6. Okay, great. So now it starts. Now the loop starts. Okay. So what is the value of I now? I is 1 at the moment and sum is 0 obviously at the initial point. So now n mod I equal 0. So what is n? N is 6. So n divided by 1. Obviously 1 6 is 6. The remainder is 0. So yes, this condition matches. So whatever the value of sum was plus I. So I was 0. Sum was 0. I was 1. 0 plus 1 gives you 1. Great. Next. What is next? I becomes 2. Great. Now the same condition again. N is 6. Right. So 6. So 6 mod 2. So 6 divided by 2. 2 3 is 6. The remainder is 0. Right. It is going to give you 0. So again condition satisfied. Again whatever the value of sum was plus the value of I. So sum was 1. I was 2. 2 plus 1 gives you 3. Great. Now I becomes 3 obviously. Now what happens? Now again the same condition happens. N was 6. I was 3. 3 2s are 6. The remainder is 0. Like mod, we are trying to find the remainder over here and the remainder is 0 obviously. So the condition again matches. Again sum whatever the value was plus the value of I. 3 plus 3 gives you 6 and the loop finishes. Why? Because after this I becomes 4. This condition does not hold true anymore and that's it. That's the end of the loop. Now what is the ultimate value of sum at the moment? Sum is equals to 6. Perfect. So now I'm checking, is sum equal n? So is 6 equal to the value of n? Yes, obviously, because user entered 6. Yes, therefore it is a perfect number. If this was not the case, then it is not a perfect number. It's that simple. We are done. Now obviously we can shorten down the code if we would like to do that. I mean obviously we can go on. We don't need to write this block. At least we can, what we can do instead, we can say system.out.println, and we can obviously close this for the moment. Println, and then we would have said this. You remember ternary operator from if else, right? If you haven't watched that video, please do watch that. That is, I think, the second video for if else, the exercise one. I have explained ternary operator there. So sum equal n. If that is true, then you print this new line, obviously new line character, and say given number number is a perfect number. If that is not true, then what do you print? Then you say given number is not a perfect number, and that's it. You can remove this and it will give you the exact same result. Oh, I forgot the semicolon. Anyway, see, sometimes ternary operators are very handy when you use it properly. And obviously you can remove this line as well. You don't need all these brackets. You can simply say, if this is the case, then you simply do this sum plus equals to I, and you're done. You can do this obviously, so you can shorten down the code. So that's pretty much it. We can save this, compile this. Okay, class compiled. Let's run the program and see if it works the same way even now. So again, enter a number. We enter 6. Given number is okay. Oh, I'm already using ln, right? So I don't need to use this /n character. I can just go ahead and remove this. Yeah, now this is great. Let's compile this and once again run this. Let's run. Okay, enter a number. I enter 6. 6 is a perfect number. Great. So it's working exactly fine. Okay, so this is how you find perfect numbers. So we're done with the first program. Now let's move on to the next program, which is going to be probably one of the easy one, that is digit counting. Oh, not with the red pen. I guess I'll use this white. Yeah. The next thing that we're going to do is digit counting. So how do you do digit counting? I'll give you the brief summary and show you the algorithm how we are doing it. Okay. Now from here on, digit counting, reverse number, palindrome number, Armstrong number, it all follows almost the same pattern. Okay. So you need to understand this in very detail. You need to listen very carefully now. Okay. So all right. Let's say I am giving a number. It can be any number, 84261, 84,261. So you need to count the digits. So how many digits are there? 1, 2, 3, 4, 5. So it will give you 5. This is going to our program. Now how are we going to design it? Let's understand the mathematics first and then we'll build the program. Okay. Okay. All right. So how do you count it? Let's see. Tell me this. What happens if this is my n? Let's say n is this, and we basically divide it by 10. What happens then? And yeah, it is an integer division. Obviously it's going to be integer. We are not going to take the flow, like the decimal part, just the integer. What are you going to get? So if I divide this by 10, what I will get is that correct? Because now it is divided by 10. This part is gone. You can try doing that. Obviously, if you like to see this in action, I'll show you. I'll open probably terminal for that. Start the J shell just to show you. Let's say we have int n, and what was the number? Anyway, let's take 84561. Okay, and yeah, that is it. That is our number. Now what happens if I divide by 10? I get 8456. Do you see what's happening? The last digit is gone. No, but yeah, obviously you have to update it once again. Like you need to say n is equals to whatever the value of n, was, it's not there now. It is the divided value now. So now n, what is the value of n? It's 8456. What happens if you do the same thing It becomes 845. What happens if you do the same thing? It becomes 84. Now what happens if you do the same thing? It becomes 8. What happens if you do the same thing? It becomes 0. And you stop. And you stop. So how many times exactly did you divide this number? Let's count. Let's start from here, okay? 1. This number is gone. The last digit is gone, okay? Then again, this second digit is gone, right? The 6. Why can I? Yeah, this part is gone. You do that again. This part is gone. You do that once again. This part is gone. You do that once again. Once again you do that. Now even this part is gone. And after that it becomes 0. So how many times could you do this operation? Because even after you do this, you're only going to get 0. So anyway, how long can you do this till it becomes 0? So 1, 2, 3, 4 and 5. It becomes now it now becomes 0. So this is why we have 5 digits. That's how we understand we have 5 digits. Now again I'm going to explain, don't worry. So we divide by 10. Now what is the value of n? N is now 8426. And yeah, keep counting. Okay, this will be in a loop. This will keep happening until n becomes 0. Until n becomes 0, it will keep on happening. So this, and yeah, you keep on counting how many times this is happening. Let's say you have a counter variable. Let's say count. You have a counter variable, okay? Count, and you keep on plus doing it. You can keep on incrementing it. Every time this division happens, you increment it. So let's start again, okay? Let's say we need, for this we need 3 variables. We need n, which say 8, 4, 5, 6, 1. We need a count variable, which initially is 0, and that's it. That's all you need, basically. Yeah, so you need to start a loop, and it will loop until n becomes 0, okay? And every time what will do? It will do n equals to n by 10. Every time it will divide n by 10, and every time it is divided, it will increment the counter. You will basically count the number of times it is getting divided. That's all. That's your program. You are done with it. How are you doing it? Let's see this in action. So what is the initial value of n? Let's take n. Let's take count. Initial value of n, 8, 4, 5, 6, 1. What is the initial value of count? It's 0. Great. So the loop starts. Is n 0? No. Great. N equals to n by 10. What is the value of n now? This is removed. So 8, 4, 5, 6. And count plus. Count becomes 1. Great. Until n becomes 0. Is n 0? No. Again you do that. You divide n by 10. So n becomes 8, 4, 5. And count plus. Count becomes 2. Is n 0? No. It is 845. You do that again. N divided by 10. It becomes 84. 84. This part is removed. Count plus. Count becomes 3. Great. Is n 0? No. N is still 84. So you do that again. N equals to n by 10. Now n becomes 8. Count plus. Count becomes 4. Count becomes 4. Is n 0? No, n is not 0. You do that once again. N equals to n by 10. Now n becomes 0. Count plus. Count becomes 5. Is n 0? Yes, it is 0. Loop stops. What is the value of count? The value of count is 5. So how many digits are there in the number? 5 digits. This is how you do it. Are you getting it? This is how you do it. That's the program. Now one important thing is that, do you see, I haven't said it will go from 1 to 10, it will go from blah to blah. I didn't say that. I have a condition that has to be satisfied, and that's how it becomes like the loop goes on, right? So when there is a condition, we do not use for loop. We are going to use, in this case, a while loop. While loop. So we are going to say while n not equals to 0. That is, in English, that what I'm saying is that until the value of n is not 0, the loop will keep on going. The moment it becomes 0, the loop will stop. Listen to me once again very carefully. N while n not equals to 0, it means the loop will continue executing as long as the value of n is not 0. The moment it becomes 0, the loop will stop. Okay, so here's our program. Let's write it. Let me close this, open our BlueJ, close it. Let's open a new program. Let's call it, what do you call it? Say count digit 7. This project is becoming heavy, I guess. Hopefully, this is why it's not responding properly. But anyway, let's open this. And again, you are going to take the input from the user. So yeah, I'm not explaining the same thing again. Don't want to make the video long for no reason. And here your loop starts. So you're going to say this. You're going to say while n not equals to 0, the loop will continue, right? Every time, what you're going to do, you're going to say n equals to n by 10, or just to shorten it, n mod equals to 10. Board does the same thing, right? I'm just shorting out the code. So n mod, n divide equals to 10. Every time it will divide by 10, and there will be, oh sorry, I forgot to declare the count variable. Say int count equals to 0 initially, right? So I'll say count plus every time plus, and finally I'm going to say if, oh not if, I'm just going to say how many digits, right? So system dot out dot println count. Oh, I'll just print the value count digits, and we are done. Say compile the program. Yeah, so run the program. Okay, enter a number. Say I am giving 84561, the same number, right? So it is saying it contains 5 digits. I'm not going into detail because, I mean, obviously I explained. I don't think you need a dry run, but if you need, just let me know. I just gave you a dry run out there, so that's why I'm not repeating stuff. So now that is it. Let's move on to the next program, which is, well, think of it like an extension of this program only. It is called the reverse number. It is the next program that I'm going to do. So now we move on to the next program, which is reverse number. Okay, let's see how we are going to build the program. Okay, um, I'll just discuss the math with you first, because the math is very important first. So again, let's take the same number. Okay, what was the number? 84561. This was a number, right? Great. Let's take the same number. Now if I tell you, how do you find the last digit? How do you take it out? Do you remember last time when we are doing the count digits, we were dividing in? So think about it once. If I divide this, what I am getting? I'm getting 8, 4, 5, 6. This is gone, right? But why is this gone? Because this is the remainder. 1 is the remainder. This is the, like, this one is the remainder. Getting it? Now in the next time we are dividing, again doing the same thing. Let's say we are dividing n by 10. What was the value of n previously? 8, 4, 5, 6. Now the value of n would be 8, 4, 5. But where is 6? 6 is gone. Gone where? Gone as a remainder. Now we do that again. We do n by 10. What was the value of, okay, let me write it properly. N by 10. What is the value of n? It was 845. What is the value of n now after dividing? Well, n would become 84. Where is 5 now? 5 is gone as a remainder. We do that again. N by 10. What is the value of n now? It's going to be 8. Where is 4 now? Well, 4 gone as remainder. Now again, we do the same thing. N by 10. What is the value of n? Value of n is 0. 8 is gone. 8 is gone as a remainder. Now think about the order. 1, 6, 5, 4, 8. What did I say? 1, 6, 5, 4, 8. What is this? That's it. That's the reverse of the number. 8, 4, 5, 6, 1, 1, 6, 5, 4, 8. You got the reverse number. So we need to take this number and store it somewhere. Then this number, then store it somewhere. Then this number, then store it somewhere. Then this number, and we have the reverse number. That's it. This time you need not this. You need the remainder. And how do you get the remainder? Using the mod operator. If you remember it correctly. Again, divide it by 10 and get the remainder. So basically we are going to do n mod 10. We will get what? We'll get the remainder or the last digit. Every time you do this, you will get the last digit. Okay. So again, let me show you with one other page. How are we going to build the program? Okay. See, finally, you need to print it, right? So what you're going to do is that let's build the program. Say you have n. Okay, let's say n is what? 8, 4, 5, 6, 1. Great. That's all you need. I mean, yeah, another thing that you need, another variable that you need is that is, say, reverse number. This is the final number that you will get. Initially set it to 0. Okay, initially set it to 0, and then you will have another digit that will be inside the loop. That will be called last digit. Again, it will be 0 every time. Okay, so are we going to do that? So let's see. We'll start a loop. Again, the loop will be in the same format. What same format? It will continue as long as n is not 0. The moment n becomes 0, the loop stops. So the same while loop, there is no change. We're going to say while n not equals to 0. Done, that's it. We're just going to say that this is our loop. We start the program here. How do you build it? So this is how you build it. You are going to say int last digit. How do you take the last digit? How do you take the last digit? You need to do this. You need to take the mod of the number. You will get the last digit automatically, right? So you're going to say n mod 10, n mod 10, and you're going to get the last digit. That's how you do it. Once you have the last digit, you're going to say again, I'm going to use yellow for this, int, not here, you know what, declare reverse number outside, otherwise it will initialize every single time. So declare reverse number outside this, reverse number equals to 0, declare it outside, and now say reverse number, and there is a formula. There is a formula. Look at the formula very carefully. We're going to say reverse number reverse number into, I mean multiply by 10 plus last digit. What is the formula? This formula you need almost in the next all the programs, the palindrome number and the Armstrong number as well. So reverse number multiplied by 10 plus last digit, and once you are done with these two statements, you just divide n, and you're going to set the value n equals to, or simply say n divide equals to 10, and your loop finishes. And finally you do system dot, I'm not writing the entire thing, feeling lazy, print reverse number, and you will get the reverse number. Now how it's working, let's understand this in a bit more detail. So I'll do this. I'll take this and I'll yeah, this looks great. Now let's understand what is happening here. Okay, we have three variables. Right? Let's start. So last digit, reverse, yeah, I need a little bit more space here to explain what's going on, and then finally n. Okay, all right, great. So let's get started. In the first iteration, what's happening? Last digit n mod 10. Now what is n mod 10? N mod 10, that what was n, by the way? N was 8 4 5 6 1. Now you modding it with 10, you get the remainder. What is the remainder? What is the remainder here? It's going to be 1. So last digit would be 1 at the moment. Okay, what is the reverse going to be? So reverse has a formula. It says reverse into 10 plus last digit. What was the value of reverse previously? It was 0. So 0 into 10 plus the last digit, which is 1. It's going to give you what? 0 into 10 is 0 plus 1. It's going to give you 1. Great. And the value of n would be what? N divided by 10. N is going to get divided by 10. So once n is divided by 10, this 1 would be completely gone. I was just finding the remainder here, but now I'm literally dividing it. The 1 will be gone. The last digit will be gone. So I would say 8 4 5 6. 1 is gone. Okay. The next iteration. Is n 0? No, not yet. So start the loop again. Last digit n mod 10. What is the value of n now? 8 4 5 6, right? I'm going to say 8 4 5 6 mod 10. I'm going to get the last digit as the remainder, so it would be 6. Okay, Again, we are going to get the reverse now. Okay, what was the formula? Previous value of reverse multiplied by 10. What was the previous value of reverse? 1 multiplied by 10 plus the last digit, that is 6. What are we going to get? 1 tens are 10 plus 6, 16, and n is going to get divided by 10. Once it is divided, this will be gone, right? So I'll say just 845. Great. Is n 0? Not yet. Start again. Last digit n mod 10. Again, you do the same thing. What is the value of n now? 845. So 845 mod 10. You're going to get the remainder. What is the remainder? This one, 5. Again, reverse into 10 plus last digit. That is going to be the reverse number, right? So say what is the last value of reverse? 16. So 16 into 10 plus the last digit, which is 5. So what are you going to get? 16 into 10 is 160 plus 5, 165. Are you seeing how it is building the reverse number now slowly? And again, n divided by 10, n will become 84. This is gone, 5 is gone. Again, do the same thing here. Now, is n 0? Not yet. So start the loop again. Last digit equals to n mod 10. So n is at the moment 84. Mod 10, you get the remainder. Remainder is 4. You're not yet dividing, you're just getting the remainder. Okay, remember that. Now in this number, reverse number is equals to reverse into 10 plus last digit. What was the previous value of reverse number? It was 165 multiplied by 10 plus the last digit, which is 4. So 165 into 10, you are going to get 1650 plus 4, you get 1654, and you divide n by 10, you get 8. Great. You do the same thing once again. Is n 0? No, not yet. So again, last digit equals to n mod 10. N is 8 mod 10. You get 8 as the remainder, because this is the only digit, right? So yeah. Again, reverse number equals to previous value of reverse, 1654, multiplied by 10 plus the last digit, which is 8. It gives you 16548, and n, and again you divide n by 10, it becomes 0. Now will the loop continue again? No. This was to be executed till the moment n was not equal to 0, but now n is equals to 0, the loop will stop, and you finally print the reverse number, which is this one, 16548, which is reverse 16548. Do you see this? This is how you get the reverse number. Now let's write the program according to that. I hope this concept is clear. This formula is very, very important. You need to understand this, because this is the same formula that we're going to use for palindrome and Armstrong number as well. Okay, so let's see. Let's close this, and we need to create a new class. Let's say reverse, just say reverse. Okay, great. I'm gonna say this. Now you start the loop. While sorry for that, n not equals to 0, you're gonna do this. You will say int last digit is equals to n mod 10. Yeah, oh sorry, I forgot to declare the reverse. Int reverse, let it be 0 at the moment. Okay, and the next int, don't declare it, sorry, it is already declared, right? So reverse is equals to whatever the value of reverse was, multiplied by 10 plus, oops, plus last digit, whatever the last digit was, and n divide equals to 10. You just divide n by 10 and you are done, and simply print it. System.out.println reverse number, and you simply print it, say reverse. That's it. Let's compile this and see this in action. That's compiled. Okay, enter a number. Let's say, oh damn, I did ln here. Anyway, let's enter this. Let's say 84561. So the reverse number is 16548. So it is working exactly fine. I'm not going for the dry run because I have already shown you how the dry run is working, exactly how the algorithm is working. So stop the video. And yeah, let's move on to the next program. Yeah, again I forgot to compile this. Yeah, perfect. Let's move on to the next program. The next program is called palindrome number. Now actually I'm going to do a lot of copy pasting from the previous program for this palindrome number. What is palindrome number? Let's say okay, let me open a new page. Yeah, so now what we're going to do is that let's define palindrome number. So any number, let's check this, it's working. Yeah, it's working fine. So any number whose reverse is same as the number is a palindrome number. So what I mean if you have a number, say 6565 or 6, like something like this. So what is going to be the reverse number? 6 5 6 5 6. Is this the same number? Yes, this and this matches. So this is called palindrome number. This is a palindrome number. If I say, if you have a number, say 1 2 2 1, is this a palindrome number? Yes. Why? The reverse would be 1 2 2 and 1. This is a palindrome number. So any number whose reverse is same as the number is called a palindrome number. So as you can understand, we need to get two things. We need to get reverse of number. How do you get that? Well, like this. The same process, we will have the reverse number. The second thing that you will check, if reverse is same as given, then palindrome, else not palindrome. That's why I said I'm going to do a lot of copy pasting. So it's essentially the same program. You are going to copy the same exact thing. It is the same exact everything. What you need to do is that you need to change over here, because ultimately n becomes 0. So how do you compare, like, if n equal reverse? Because I mean, n does not even exist. N has already become 0. So the given number was 84561. It does not exist, right? So what you're going to do is that you make a copy of n. You make a copy of n, and then you use that. Like, let's say this is, let's call it n2, right? Let's call it n2, and n2 is a copy of n. So now what happens? N2 becomes 0. N2 becomes 0, but n is still 84561, right? So you're just going to keep a copy of it, and finally you're not going to do this. You're going to say if a reverse equal n, then yes, palindrome. If not, then not palindrome. It's the same thing. Okay, so let's write the program quickly. I'm not wasting a lot of time on this because obviously it's palindrome number. It's really easy. It's the same thing as finding out the reverse number. So I'm going to copy the entire thing. Okay, let's copy the entire thing. I'll close this. I'll create another project, obviously. New class. Say palindrome. Perfect. Inside this, we delete everything and just paste the same thing, whatever we had written. Oh yeah, obviously class name does not match, so hold on, you have to make it palindrome. Why? The file name is palindrome, right? Palindrome, yeah. So you need to do two changes, just the two changes. Okay, so you are going to say you have a copy of n. Okay, so you're going to say int n copy, or write whatever you like, and you just copy it, copy the value of n into n copy. Okay, and don't touch n, don't touch n. If you are like, you are dividing every time n, right? You're dividing every time n, so don't do that, don't do that. Play with the copy, not with the original. Okay, copy, yeah. So what are you doing? You're just taking a copy of n, and then you are dividing and doing all the stuff that you were doing. Okay, yeah, also do this instead, n copy. So inside the loop you do not touch n, you touch only n copy, not the original one. Okay, you remember that. Finally you, why I'm deleting this, println. I'm going to use ternary operator because it's way faster. System.println. I'm going to say this, say if reverse equal n copy, then it is or just write given number is a palindrome number, else given number is not a palindrome number. So I'm just comparing. If the reverse number is same as the given, oh no, sorry, you are already destroying n copy out here, right? It's going to be 0 at the end. So no, not n copy, sorry. Yeah, so if reverse is same as n, the given number, then it is a palindrome number. If it is not, then it's a not palindrome number. So save this. Oh yeah, compile. That's compiled. Let's see this in action. Enter a number. Say I am entering 133 or maybe 131313. It is not a palindrome number. Okay, so let's run this once again. Yeah, run again. given a number, enter a number. So I say 121 or 131. It is a palindrome number. Why? Because the reverse of 131 is 131. Yeah, that's why it is a palindrome number. So it's perfectly working fine. This is all about palindrome number, and the final program we are going to talk about Armstrong number, and we'll be done. So let's understand how we are going to build the program, but first let's understand what exactly is Armstrong number, because that fundamental understanding is definitely necessary. So we are going to write our last program for the loop section, that is Armstrong number. Let's see what it is. So basically, even if I give a nice definition, it would be hard to understand. All right, so let me give you some examples. I can say that 153 is an Armstrong number. How do I say that? Okay, how do I say it? So first, count the number of digits. 1, 2, 3. So how many digits? 3. Great. Now, yeah, keep that. So count is 3. How many digits? 3 digits. Great. Now what are you going to do? For every number, take it, and there is only way to take individual numbers out of this, the way we took out reverse numbers, right? Like that only, like you can do in mod 10 and get the last number, right? So with that, you take the number and you do exponent, that is to the power of 3. Okay, what it would be? 3 into 3 into 3, 9, 27. Keep it somewhere. Let's say I have a variable called sum equals to 0. Okay, keep it. Okay, so what is the current value of sum? 27. Great. Now take the next. How do you take the next number? Again, n divide by 10. Like the last time we were doing the reverse number, it's kind of same. So we are going to divide it. So definitely 3 is going to be not there, so only 15. So again, n mod 10. So what are you going to get? You're going to get 5. How many digits? 3. 5 to the power of 3. 5 into 5 into 5. 5 5 is 25. 25 5 is 125. So add this with the current value of sum. What was the current value of sum? 27. So 27 plus 125, the current value of sum, let me calculate as well. Yeah, so 125 plus 27 would give me 152. This would give me 152. What is the current value of sum then? 152. Great. Okay, again divided by 10. This part is gone, only 1 remaining, right? Again do the same thing, n mod 10. What do you get? Obviously this last one, so you will get 1. Now how many number of digits? 3 number of digits. So 1 to the power of 3. So 1 into 1 into 1 is obviously 1. So add this with the previous value of sum. What was the value of sum? 152, right? And what is the current, what is this? 1 to the power of 3, 1. So add both of them, 152 and this gives you 153. Now check this. Initially the number is 153, and after doing all of these you get 153. So this is what we call an Armstrong number. Okay, now Armstrong numbers can, like, it can be even bigger as well. Let me search for some of the examples. Yeah, so for example 370, this is another example. 370, let's take an example, or maybe take a 4 digit. What about it? Let's take a 4 digit number and see. For 4 digit, okay, let me open it. For 4 digit, 8208 is a Armstrong number. How do we get it? Again, do the same thing. Take individual. Okay, first count the digits. How many number of digits? Okay, do that. 1 2 3 4. So how many digits? Count 4. Okay, now you take each number from the back. How do you do it? You start a loop, and until the number is equal to 0, you keep on doing the same thing, that is n mod 10. What do you get? You get 8. So 8. What was the how many digits? 4. 8 to the power of 4. So I'll take help of calculators now. So 8 to the power of 4 gives you 4096. Okay, and yes, obviously you have a some variable. Initially it was 0, but every time you do this you need to do sum plus equals to whatever the value is, like this value, whatever this value is. Okay, you keep on adding. So what is the current value now? 0 plus 4096, so it will be 4096 current value. Again, now you finally divide it in by 10, so this goes out, so only 820 remaining. Again do the same thing in mod 10. In mod 10 what do you get? 0. So 0 to the power of 4. Now 0 to the power, it doesn't really matter. You will get, I mean, you will get some, obviously you know, right? 0 to the power of anything is going to be 0, like 0 into 0 into 0 into 0. What are you going to get? You're going to get 0. 4096 plus 0, it is still 4096, no change. Okay, 10 2. I mean, yeah, you divide again by 10, get 2. 2 comes into the picture. 2 to the power of 4. How? Why 4? This is why. So 2. Okay, I'll directly calculate. 2 to the power of 4 gives you 16. So 16 plus 4096. 16 plus 4096 gives you 4112. Okay, now you do again and divide by 10. Okay, so now only 8 is remaining. Again you do the same thing in mod 10. You get it 8 to the power of 4. Now 8, okay, let me do that. 8 to the power of 4 is again 4096. So now 4112 plus 4096. Let's calculate. 4112 plus 4096 gives you what? 8208. Is this same as this, the original number? Yes, this is why 8208 is an Armstrong number. So there are two things. Okay, there are two things. First step, I'll write the steps in detail now. Yeah, so first step, count digits, count digits. Okay, second thing is start a loop while, and yeah, do not touch the original number, always touch the copy. Okay, touch the copy. So let's say n copy, you need another copy here, so you need actually 2 copies. So let's call this n copy 2. Okay, why n copy 2 is not equals to 0? Okay, the loop keeps on going. I mean, this loop will continue till n copy 2 is not 0. Okay, and for every time it will do 3 things. First of all, it will, okay, you need to declare another variable. Let's call it arm. Okay, int arm equals to 0. Keep it outside the loop. Okay, and so yeah, every time what you're going to do, you're going to say you will have a variable, let's say int last digit, just like reverse number, right? Int last digit, but yeah, it's the same thing. N copy, you are not going to touch the original number, so n copy 2 mod 10. Okay, you will get the last number. Now this arm variable we'll say arm plus equals to, I mean, every time it will add to arm this thing, math dot pow. Now I will tell you how to import math and all when we study math library in detail, but just so you know that if we want to take the power of something, we need to import this math library and we need to use this function inside math library. I will definitely explain you, but all math, let's say I say math dot pow 3 comma 2, this is how it works. So it will do 3 to the power of 2, so 3 into 3 it will give you 9. So this is how it works. The number and the power. It will give you number to the power. It will give you the result. So this is how it works basically. And yeah, that's it. That's how it works. That's all you need to know at the moment. So math.pow, whatever the last digit to the power of the number of digits. Okay. And then once you are done, you do n divide equals to 10. That is you eliminate the last number. That's what you do. And that's it. That's it. The final and the third thing is, if arm equal n, if this after adding all the numbers is equal to the given number by the user, then it is Armstrong. If not, then not Armstrong. Else not Armstrong. Simple. If it is Armstrong number, how would you know? After adding all these values, it is the same as the given number, then it is Armstrong number. Else it is not Armstrong number. It's that simple. So we're going to copy paste few things. This is going to be the same. This is going to be the same. This is just an addition, and yeah, this is the only new thing is this. Rest we all know. We have done this previously for palindrome. Have done this for counting digits. So it's basically we have done this for reverse numbers. So it's basically the same thing, compiling everything to make a new program. So let's write a new program on this. And yeah, it's best that you do not touch the copy. Oh, I'm sorry, I wrote n. I need to write n copy 2. Do not touch the original number that is given by the user. Always make copies, 2-3 copies, no issues. So let's write the program first. Let's close this and again make a new class. Call it Armstrong. Now there will be a slight change. I will show you. That slight change would be that of course you are entering the number. The user is going to enter the number. So obviously you need the scanner class. Import java.util.scanner. You need this for the user to enter the number. But you need another thing, that is the math library. How do you import math library? Import java not util dot lang dot math. This math library has all the functions that I'm talking about, right? So you need this library to work with power and exponents and all these things. It's all about maths, and I will definitely cover this in the next video where I teach math library in much more detail. So again, our good old scanner, see new scanner system.in. Enter a number. I'm going to say int n. You are taking the number from the user right now. Next int, and you're done. But before moving on, please do not touch this variable. Make a copy of it, that's fine, but don't touch this variable. So make some copies, say n copy 1, or just yeah, let's say n copy 1, and we'll just copy this. Copy n. What is the value of n copy 1? Well, it is same as n. Int n copy. You need another copy, so n copy 2, and again, what's the value of n copy 2? Same as n. Okay. Oh yeah, I forgot to put the semicolons. Anyway, and you can start your program. But yeah, you need a few things as well. you need to keep a count of the digits, remember? So int count, this is how you count the number of digits. Obviously initially keep it 0. You need the Armstrong variable, let's call it arm, again keep it 0. So this is where you keep on adding the values, right? That's it. And do what you do. First, I'll write the comments as well. Count the number of digits. Okay, this is the first thing that you're going to do. So how do you count it? While n not equals, no, don't touch the copy. I mean, don't touch the original one. Use some copy. N copy, maybe n copy 1 not equals to 0. This loop will run as long as n is not n copy is not 0. Every time what you're going to do, you're going to say n divide equals to 10, and oh no, again not n. I'm writing the same thing, I'm doing the same mistake. Yeah, n copy 1 mod n copy 1 divided by 10. Every time you will divide n copy 1 by 10, so every time it one of the digits will eliminate, and you will say count plus plus. You will keep on incrementing the count every single time as long as it is 0. So you will have the number of digits over here. Now the next thing that we're going to do is add the actually take individual digits and do pow. I mean, take the power, do pow, and add to arm variable, right? So again, same thing. Do not touch the original number. Say n. So that's why n copy. Go with n copy 2 not equals to 0. Same thing. Now you're gonna say int last digit, like we were doing previously, right? Same thing. N copy 2 mod 10. We're going to take the last digit. After that, you have your arm variable over here, declared over here, arm variable. So arm is equals to, actually not even you can directly arm plus equals to, now you have the last digit, remember? Now just do this math.pow the number that is last digit and the count of the digit, I mean how many digits are there, right? That thing, and then simple, you completely eliminate the last digit by dividing it by 10, and yeah, that's it. And finally, third thing, check if it is Armstrong. Okay, I'm going to directly write the print statement using ternary operator system dot out dot println, and I'll write the condition. What's the condition? Arm equal n. If it is same, then print this given number is a, okay, let me maximize it. Given number is a palindrome number. If that is not the case, then say given number is not a palindrome number, and you are done. Let's see if this works perfectly. Oh, one more thing. Math.pow always gives you numbers in decimal. Okay, you don't need decimal, you need integer, proper integer. So typecast it into integer, otherwise you will get some point value. Like even if like, let's say you 2 to the power what is 2 to the power 3? 2 into 2 into 2, right? What is 2 into 2? 8. But you won't get 8, you will get 8.0. After that your calculation will badly mess up, so that's why don't do it, just keep it int. Okay, typecast the value, because math.pow will always give you something like if I say math.pow 4,2, what's this? This is 4 into 4, 4 to the power of 2, right? 4 into 4, what I'm gonna get? I'm gonna get 8, but I am actually going to get 8.0. That's why That's why if you do something like this over here, to come here and say, hey, I need integer only, so you won't get 8.0, you will get 8. This is why you do it. Again, compile this, class compiled. Let's run it and see if this works or not. Armstrong. Okay, enter a number. Say I'm gonna enter 153. Okay, 153 is a palindrome number. Great, it's working. Let's check with our 4-digit number, right? Run this once again. What was our 4-digit number once again? It was 8208, right? Let's try 8208. This is a palindrome number. Great, it's perfectly working. Again, let's run this once more. What about some random number? Let's have 121. Will this work? This is not a palindrome number, so this is perfectly working fine. Okay, now let's see how it is working. Okay, I have already shown. If you are not interested in the dry run, then you can stop the video, you are done. But if you are interested into how it is exactly working, although I have shown you, I'm going to show you once more. You can see. Okay, I'll take a screenshot first. So this is all about Armstrong number. Start the dry run and we'll show you what's going on over here. Okay, let me take a screenshot, and this time I need a big screenshot. Pasting this pretty big. Let me just switch it down. Still very big. Yeah, this is good. I guess a little bit more would be better. Yeah, this works. It's good. Let's see how this works in action. So again, for our experimentation purposes, I'll take 153. Okay, I'll take one because 153 is obviously a palindrome number, so I'm taking that example. Yeah, let's say. Okay, so what's happening first? You import the scanner class. You need to take input from the user. You import the math class from java.lang, and you're going to use it, right? So the user enters number over here. Let's say the user gives you 153. You make a copy of n 153. You make another copy of n 153. You have a count which will count the digits. You have an arm which will calculate things. So, and you set both of them to 0. Okay, great. So let's run the first loop first. Okay, first loop. What variables are you using? You are using count and you're using n copy 1. So what is the value of n copy 1 first? N copy 1 and count. Okay, so again, initially this is going to be 153. Why? Because user entered 153 and n copy 1 is a copy, and count is obviously at the very beginning, it is going to be 0. So it starts. First thing that you do is you divide n copy by 10. So 153 divided by 10, what do you get? You get 1, 5, 3 is gone. This last digit is gone. Why? You divide by 10. It's gone. And count plus plus. So you increase it by 1. Again, what is the condition here? This loop will execute till n copy 1 is not 0. It is not 0, it is 15. It will continue again. So again you divide n copy 1 by 10. You get 1. Why? This part is removed. Divide by 10, right? And count is increased to 2. Is n 0? No, it is not equals to 0. So again it will execute. Again you do the same thing. N copy 1 by 10. If you divide 1 by 10, the integer part you need. So the integer part would be 0. That's it. And your count would be 3. Now, will this execute anymore? No. Why? Condition is false. Why condition false? N copy 1 is now 0. And the condition is this loop will run till n copy 1 is not 0, and it is 0, so the loop will stop. So your final value that you get for this is, let me write over here, count is going to be 3. Perfect. Armstrong is still 0, so this loop is done. Let's go to the next loop. Okay, what are the variables that we're using? We are using n copy 2, last digit, arm. Yeah, that's it. Great. Okay, but for this I need to draw some more lines, let me draw. So okay, first things first, what are you using first? Last digit. Let's write it that way. So inside the loop, first things first, and that is last digit. Then what's next? Arm. Let's call it arm. We're going to take this, and finally we are using n copy, right? So n copy 2, n copy 2. Okay, now let's see this in action. What's happening here? Great. So loop starts. Why loop starts? This loop will again run as long as n copy 2 is not equals to 0. And by the way, what was the value of n copy 2? It was 153, which is not 0, so it will execute. So last digit is n copy mod 10. So n copy 2 mod 10. So basically 153 mod 10 gives you the last digit, which is 3. Great. Arm plus equals to int math.pow last digit comma count. What this means? Integer part of okay, previously what was the value of arm? Previously the value of arm was 0. So 0 plus, you're gonna say, int part of pow function, math.pow last digit comma count. Now what was last digit? Last digit is 3. What was the count, by the way? Count was 3. So 3 comma 3. So 3 to the power of 3 gives you 3 into 3 into 3. 3 3s are 9, 9 3s are 27. Great. And finally you do what? N copy divide by 10. So you eliminate the last digit. So 153, it was the previous number, it will be 15. 3 is gone. Why? You divide by 10. Great. Now is n copy to 0? No, n copy 2 is still 15. So you do the thing again. 15 mod 10. You get the last digit, that is 5. Now you do the same thing. Arm plus equals to, that is the previous value arm, that is 27, plus int part of math.pow last digit. What was last digit, by the way? Last digit was 5, comma, what was the value of count? Like last digit comma count was 3, right? Number of digits is 3. So 5 into 5 into 5, 125. Okay, not 125 actually, because yeah, obviously, I mean 5 to the power of 6 is 125, but then 125 plus 27, 125 plus 27 gives you 152. So the current value of arm is 152. All right, great. And then you do the same thing again. N copy 2 divide by 10. That is, you remove the last digit, that is 1. So only 1 will be remaining over here. Oops. Yes. Yeah, only 1 will be remaining over here. Okay. All right. Is n copy 2 0 yet? No, it is 1. So again, this will continue. Again, you take the last digit, n copy 2 mod 10. N copy 2 mod 10, 1 mod 10 obviously gives you 1. Last digit, that is the last digit, nothing else. So again, arm plus equals to previous value of arm, which was 152, plus int portion of math.power, that is pow. What was last digit? 1. What was the number of count? 3. The power of 3, right? Last digit comma count. Last digit comma count. Yeah, 3. So 1 to the power of 3 is obviously 1. Sorry, yeah, 1, but 1 plus 152 gives you 153. And again you do divide n copy 2 by 10, you get 0, and the loop will stop because now n copy 2 is 0. It will run like this loop was supposed to run as long as n copy 2 was not 0, but now n copy 2 is 0, it will stop. That's it, and you have your arm variable. That's it. Now you're gonna print simply. You're gonna check if the value of arm, that is 153, equal to n. What was n, by the way? N was 153. Is it equals to 153? If yes, then it is a palindrome number. If not, it is not a palindrome number. That simple, nothing else. Okay. Phew. So we have covered this as well. With this, we have done all this. Let's count. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have done 16 programs. That's a lot of programs. Now, if you practice all of these things, I really hope that you do not have any more problems with using loops or logic building and stuff like that. So I have plans. So now that we are done with the very bare bone fundamentals of programming, and now we're going to see the last fundamental, what I would call, of any programming language, that is function, in the next video. I have prepared a chart of topics and we'll be covering functions. After that, we'll take a look at the string and the math library. So that was it for this video. Hopefully you will learn a lot from this video. So see you in the next lecture. Bye bye.